Hello Finxters and welcome to a new Pandas tutorial. In this tutorial we will learn about working with datetime in Pandas. We will learn how to convert strings into datetime objects, how to create date ranges in various ways, and how to work with absolute time units. And we will see how to restructure our date values and all this using several Pandas functions. First of all, let's clarify why to work with datetime. We very often find data sets with datetime values, whether it's stock data, weather data, or the price development of Bitcoin or something. We often find datetime values, so it's important to know how to work with them and how to use the functions that Pandas provides us with. So let's get started with the coding. First of all, we will see how to convert an argument into a Pandas datetime object. And first of all, we will have a look at a simple data frame. We import the Pandas library. We create the data frame, which contains a date column and a num column. And the output is a typical Pandas data frame. As I said, date column and num column. The num values are just values from 0 to 3. They are not really important here, so it's just some random numbers. And first of all, let's check the data types of this data frame. We do this by saying df.dtypes. And as we can see, the num column is integer because it's integer values, and the date column is an object data type, and the object data type refers to strings and mixed data types. So right now Pandas does not recognize it as a date column or as a date data type, but we can change that using the toDatetime function, and this is how we do it. df, and we say df the date column of the data frame, pd.toDatetime, and again inside here we state the column that we want to change. And now that should be the date column should be of the datetime data type, and we can approve this by again checking the data types of the data frame. Dtypes, and now we can see that the date column changed to datetime data type. So now Pandas sees that as a date value, and now we can set the date column as the index. We typically do that to some analysis easier. We do it like this: df equals df.setIndex. That's how we set a new index. And inside here we state date, because we want to set the dates column as the index of the data frame. And now we can see that the structure has a bit changed, because now the date column is the index of the data frame. And now we can do all sorts of calculations and analysis with that. There are lots of opportunities. We will just do one example here. For example, we could calculate the sum of the num column in the month of May. We would do it like this: df num column dot log, and we log the month of May. We do it like this because it's the 5th month of 2021, and we say dot sum. And now this is 5, and as we can see in the data frame, the sum of the num values of the month May is indeed 5, because 2 plus 3 is 5. And now we will learn how to work with date ranges. In the data frame we created here, we created the date values manually. We type them in manually, but if we want to create greater ranges, it's pretty annoying to type them all in. But there is the Pandas date range function, which creates, as the name suggests, a date range. And we do it like this, pd.dateRange. And there are different opportunities how we can do this. First, we set a starting point using the start parameter. Let's choose 1st of January 2021, and we could set an endpoint. That could be the 31st of January 2021. And this gives us a datetime index with a date range of 31 days. And as you can see, this is way easier than typing them all in manually. It would be possible, but a bit inconvenient. Yeah, if we don't have a specific endpoint, we could also set the periods parameter. And this is how we do it. Again, pd.dateRange. Again, we set the starting date. But this time we do not set an end date, but we apply the periods parameter. And let's say we want to have, again, 31 periods. And this is the same result. We get 31 entries, 31 dates. And yeah, it's just another approach. Maybe we want to have like, we don't know how many dates we want, but we have an end date, or maybe we don't know when the end date is, but we have a number of periods that we want to apply, and that just depends on the use case. And if we don't want to have like a daily frequency, we could also change that by applying the frequency parameter, or freq, like F-R-E-Q. And let's again, or let's this time do 10 periods to do 10 months. And we set the frequency parameter to M, which stands for monthly. And as we can see, we now don't get one day after one day, but we get several months. 31st of January, then we have the 28th of February, and it's always the end date of the month, and this is a monthly frequency. We could also change that to hourly. Instead of M, we apply a big H, and this is like an hourly frequency, 10 hours on one day, but with an hourly frequency. We could also, especially when working with stock data or financial data, it's sometimes we only need the business days, so Monday to Friday, and Pandas provides us with a function that can actually achieve that. And this is the B date range, which stands for business date range, and it only applies to business days, which can be quite useful. We set a starting point or starting date, and again an end date. Let's take the 15th. And this creates a datetime index with only the business days. As we can see, there are the 2nd of January is missing, and the 3rd, because these are not business days. And yeah, we only get like the business days of this date range. We can also resample the datetime values. Let's create a new data series for that to show you how it works. Let's again create a date range as the index. So this is the series that we are using. It's just some dates and a value or values assigned to each date. And if we have a data series like this with dates and values assigned to them, could be of any kind, the values, we might want to resample that. And for example, we could ask what's the mean value for every 3 days, like not for every day, but for every 3 days. And maybe is there a simple way to get that kind of information? And turns out yes, we can just use the resample function. So we sample means we are restructuring basically the dates. And if we type in 3D, that means 3 days. So we don't take every day, but like every 3 days, and we calculate the mean of every 3 days. And as you can see, now we have the mean value for every 3 days. This doesn't have to be the mean value. We could also apply the sum. And this would sum up the values of every 3 days. And we can also, especially when we have larger data sets, it can be difficult to tell the frequency, and we might want to get that information. And this is where we can use the infer_freq method, which, as the name suggests, it infers the most likely frequency. Let's create a date range and call it range. We have a starting point and an endpoint. And let's also define the periods. So if we see that we have a starting point, the January 1st, and an endpoint, the 31st of January, and 31 periods, we might say, okay, the most likely period is, in this case, obviously daily. So in this case, it might be not necessary to apply that function, but in other use cases where it's not so clear, it's very useful. And we can just apply this by stating pd.infer_freq. And inside the parentheses, we put in range, which is the date range. And this outputs d, which stands for day. And so our suggestion was right. It's a daily frequency. But as I said, in larger data sets, the frequency is not always that clear as it is in this case. And now we head over to working with time deltas. By now we've only worked with specific dates and specific timestamps, but sometimes we need to work with absolute time units. For example, 2 days, 40 minutes, etc. In Pandas, these are called time deltas, and they represent absolute time differences. And we can use the toTimeDelta function to convert any arguments into a time delta object. For example, pd.toTimeDelta, let's say 5 days, 5 minutes. And this creates a time delta object. And we can see that the 5-minute structure changed to this representation, 00, 05, 00. It's just another way of representing that. We could also apply a list with multiple absolute time units, and this would look like this. Again, pd.toTimeDelta, and inside here we apply a list within square brackets. I don't know, let's say 5 days, 3 seconds, 11.3 milliseconds, and 3 weeks. And this creates a time delta index with all these time delta values. So what can we do with time datas? We could, for example, create a data frame with one column representing dates, like we've seen before, and another column with time datas, and they like count the absolute days. And let's just create that. We call it df2 because we already have df1. We create a data frame, and we have the date column, which is a date range with a starting point of, again, January 1st, and 31 periods, and daily frequency. And we have the, let's call it number of days, or number days column, which counts the days or represents the absolute number of days. And we can do this by saying pd dot time data range, which starts at 1 day, because that's the first absolute time unit, and it has 31 periods. And the output looks like this. Has the date column with the unique days, like we've seen before, and the number days column, which represents the absolute number of days of each date, basically. So, for example, the 5th of January is like 5 days from January, for example. So all in all, working with datetime values is a very essential skill, because we often find data sets with date values or time values, as I said, in stock data, financial data, but also in other use cases. And yeah, that was the tutorial. I hope you liked it, and I see you in the next one.